Welcome everyone to our second webinar in Generative AI Spotlight series. First, a little bit about the series. In this webinar Spotlight series, I'm representing Informs. My name is Ece İzgi. On behalf of Informs Analytics Society and Practice Section groups, our objective is really bringing the Informs community together with distinguished leaders, experts, and practitioners from both industry and academia to talk about this emerging domain of generative AI and the underlying science, technology, and more importantly, the application space. So essentially, we really want to hear on what industry is working on, what academia is working on, what actually works in the field, what doesn't, right? What scales, what doesn't. And really develop a robust understanding of new frameworks that are being experimented and new mental models and providing the practitioner community the chance, the platform to ask questions and exchange notes on the new possibilities in science, technology, and the mobilization of these new approaches within enterprises and other settings, commercial or otherwise. So today I'm hosting an amazing team from Microsoft to talk about supply chain management, which is pretty close to our hearts as the OR practitioners, and of course, extremely strategic for almost every industry in the ecosystem. Team will talk about their work at the intersection of cloud technologies and operations, OR and AI. When I say AR, both traditional AI and generative AI, and how these domains, tightly integrated domains, can influence one another in designing more resilient and responsive supply chain systems by modernizing the supply chain optimization practices with generative AI. So you will sense a kind of an evolution of, algorithm design, the influence of generative AI and LLMs within the OR algorithm design, and then decision model design, then business application design, finally integrating these new layers of intelligence to the business technology systems like ERP. And then they will also share their work and vision on the progression of the field with autonomous systems and beyond. So a little bit about myself. I'm Ece İzgi. I work at the intersection of technology, cloud, data, and AI space, and also have taken various roles at Informs, currently leading a few initiatives to bring industry and academia together. Now, I will let the team introduce themselves. We have leaders and researchers on the call. I want them to, talk a little bit about their focus areas, and then we will move to the presentation. Now, throughout the presentation, feel free to share your questions and thoughts in the chat. If the team can accommodate answering those while the talk is going on, they will. Otherwise, we will have a separate Q&A at the end of the presentation, last 10 to 15 minutes. So I will now hand it over to the Microsoft team. Georg?
Yeah, thank you, and good morning, good afternoon, and happy Friday. Also, thank you for the invitation. Looking forward to our conversation. Also, my name is Georg Lanschnick, as part of the Microsoft product team, responsible for the Dynamics ERP portfolio. I will explain a bit more later on what's behind there, but basically leading the product teams, also the teams for defining what we're building, and the engineering teams who hopefully then deliver the solutions in specification, time, and quality.
Hi, everyone. I'm Beibing. So I'm a senior researcher from Microsoft Research. My background is in machine learning, deep learning, and artificial intelligence. And at Microsoft Research, I'm conducting research using GenAI tools such as large language models for supply chain optimization, decision-making, and intelligence.
And hi everyone, my name is Konstantina. I am also part of Microsoft Research, the machine learning and optimization team. And my background is in operations research and optimization, lately focusing a lot on cloud applications, including supply chain management, data centers like power efficiency, and so on.
Yeah, hi everyone, my name is Ishai. I lead the machine learning and optimization team at MSR. As the name suggests, these are also my research interests in the intersection of machine learning, optimization, and systems. And happy to be here. I see that we broke the record of attendance, so that's nice. Thank you all for attending.
Thank you very much, team. Now I think we can move to the presentation.
Yeah, so let me share. Let me know when you can see it.
Yes, we can.
Okay, awesome. So Isai, do you want to start?
Yes, but do you want to do some? Okay, now it's good. Yeah, so you know, a little bit about the agenda for today. So we'll start off with our research team. We're going to talk about what the project that has been keeping us busy for almost 2 years in this space, which is called the OptiGuide. Then we'll hand it over to Georg to talk about autonomous ERPs. And actually, interestingly, there's a lot of you know, common ground between the research vision and some of the things that Georg will present and highlight. And then we'll come back to discuss some more like ongoing research and future research directions in this space. Yeah, so as I mentioned, our MSR project is called OptiGuide GenAI for Optimization and Decision Intelligence. So I just want to kind of highlight the high-level vision, and then I'll hand it over back to Konstantina to discuss some details. So in fact, OptiGuide is more general than just supply chain management. We call it like an end-to-end decision intelligence. And here you can see a schematic view. Again, it's not a system, it's more like a conceptual view of what we have in mind that drives a lot of our research and innovation. Is this kind of what you see is this loop where a human may have some decisions to make. So like, let's say some scheduling problem or some logistic problem, manufacturing, procurement, whatever. The human wants to describe his problem in plain language, which will in turn get translated through some block, some code will get translated into some algorithm, which will fit in the, which will go into the application. It could be a supply chain application, and there, you know, the application consists of a solver or some algorithm and the data itself. And then the human can also interact with this application. And that could be like all the arrows that you see here are bidirectional in the sense that, you know, the human, for example, and that's the block that you see, insights and recommendations, the human may ask questions such as what if questions, you know, scenarios, like what happens if we do something else and all that. Konstantina will talk about this. But it can also come from the application itself that can provide insights and recommendations to the human. So all of that is bidirectional. And where is GenAI here? It's actually everywhere. So it's it facilitates the communications between the blocks, but it also drives some of the designs in the blocks, in these building blocks themselves. And we're going to see examples both from our research and our work with the internal cloud supply chain, as well as in Georg, where he will talk about like concrete product line and vision with ERP systems. So this is really an exciting area, and you know, exciting times to be in the sense that one thing that I'd like to emphasize is that, and something for you, for everyone to think about is that, you know, GenAI can do a lot of things today, but also we gotta, at least our approach has been that we still think that certain things, you know, at least in the coming years, cannot be done by GenAI. For example, you know, solve very tough integer linear programs and all that. And the idea of OptiGuide is just to merge and kind of work in concert with more traditional, you know, algorithms tools, and not to dump them and just do everything with GenAI. So one thing that I think would be interesting in this talk is how do we combine like existing technology with GenAI as we make progress and with GenAI and models themselves. So I'll stop here and hand it over to Konstantina to put some content into this vision that I've been discussing. Thank you.
Thank you, Shai. So I will start with what was our beginning in this space, as well as the customer zero for OptiGuide that Shai described. And that is Microsoft's own cloud supply chain. So this is a supply chain process to bring in new hardware into Microsoft data centers. So using some demand projections, we have a bunch of decisions to make. For example, what supplier to use for its demand, timeline aspects like schedule when to ship from the warehouses to the data centers, as well as select the best location of the demand inside the data center. So when we started working in this space, these decisions were made manually. So our first step was actually designing the optimization approach. And we did that based on mixed integer programming. So this optimization solver would generate the optimal supply chain plan. So it would say for its demand how exactly to fulfill it. And then the supply chain planners would take that plan and execute it. Now, there were a few challenges here. The first had to do with the fact that the problem by itself is pretty complex. So a lot of constraints, objectives, etc. So it's not easy to intuitively understand what is happening. At the same time, information changes over time. So new demands may arrive or something may change on the supplier side. So we need to re-optimize often, and we do that in a rolling horizon approach, which may cause the optimal plan to evolve over time. And finally, we have a very large scale. So we're talking here about the entire cloud fleet, and you can imagine what that means at a Microsoft level. So we are handling thousands of racks every month across hundreds of data centers. So as you can understand, with all this complexity, it's not easy to understand exactly why in the supply chain plan each recommendation is being made. And it's very natural that the supply chain planners have questions. So for example, they may ask why a demand was not fulfilled, or why did we use supplier A and not supplier B that they think would be better. So to address these questions, the way it worked was that they need to start an inquiry process that would involve multiple people of different expertise, for example, PMs, data scientists, engineers, that have to go and actually try to understand why the optimization solver suggested whatever decision for that particular demand that the planners were interested in. And this process used to take days. So we have an average of 2 days just with all this back and forth between people and the manual handling of the requests. So to address this challenge, we designed OptiGuide, which is an LLM-based framework to better explain optimization. So OptiGuide enables asking questions about the supply chain plan, including what-if questions, like if they want to explore some different scenarios, etc. And the way it works, so at the high level, we start with a user question. So this can be in plain English. And this question is getting translated with the LLMs into optimization code. For example, let's say the user asks, can I dock that particular demand, let's say a week earlier? So with the translation with the LLM, we would add a new constraint that enforces that earlier dock date. Then OptiGuide runs the optimization solver behind the scenes, and the output is again translated into English with the LLM. For example, one response here could be, yeah, you can do it, but it would be 2% more expensive, for example. And we have deployed this framework in production with the cloud supply chain team, and it's currently handling a lot of the scenarios and the questions that the users are interested in. And it has actually reduced the days that I told you before to just minutes to get answers to all of these questions. And as Isai mentioned, we have been working in this space for about 2 years now. And actually, what I described was one of the first works that came out in this area. So if you remember, ChatGPT came out at the end of 2022. We had already OptiGuide in production and the report out by middle of 2023. And since then, in our team, we have been working on multiple directions. That includes small language models, as well as additional topics that Babin will describe later in the talk. So now let me show you a quick demo of OptiGuide. So here, Okay, sorry. So here the users can ask questions about the supply chain plan, for example, about the dock dates or the suppliers. And OptiGuide can return information like the impact something would have on the cost, or if something is not possible, let's say the supplier is not compatible, surface that information. And this is just one view of OptiGuide. So here the user initiates the interactions. We also have the opposite. So where the LLMs can initiate interactions with the users, for example, they can look, OptiGuide can look into the supply chain plan or historic trends, and it can generate insights. For example, where you need more capacity, or some demands may need special attention, and actually also surface these recommendations to the user that can then decide whether they want to act upon them or not. So let me pause here to see if there are any questions, or we can move on to the next part. Yes, eh?
Yeah, yeah, I think we can turn it over to Georg.
Okay, thank you. You should see my screen. So great to be back for the conversation, and Isha and team, thank you for setting the context from a research perspective. What I would like to do is to give you also the product perspective as to how do we leverage these cutting edge technologies and research basically MSR is doing and trying to productize this. Also we cannot expect that every customer has this unlimited amount of data scientists and can tackle all these challenges. We try to basically bring this as part of our products. So I wanted to briefly share our vision, also give you a little bit of broader perspective, and then how optimization basically fits in our supply chain planning scenario. So before we maybe dive into the supply chain planning, I wanted to maybe talk a little bit about the broader strategy we have and what is really driving our investments. As we have this vision of autonomous ERP, and of course, as you can imagine, agents will be part of it. Also, the more agents you have, the more autonomy you can basically create. But I wanted to maybe also spend just a couple of minutes just on what is ERP. So ERP is just a system that helps businesses to manage and integrate their core processes. Also core processes for businesses like accounting, supply chain, inventory, human resources, and you want to run basically everything in a single application if possible. And why is this important? Because at the end, every business tries to improve the efficiency, try to streamline operations, of course, reducing manual efforts, getting real-time insights, and of course, collecting data for decision making. And that's basically what ERP is trying to help you. I was just checking. Yeah, you can still see my screen. Perfect.
Yes.
So basically, at the end, every company in the world needs an ERP system, to run their business. So autonomous ERP is fundamentally a little bit changing how ERP systems are built and how organizations work. So if you think about let's call them now legacy ERP solutions, they are forcing basically more to be reactive. As you're trying to enter data into the system via forms into a database, but you're mostly looking into the rear mirror. It's basically predefined business processes you're trying to carry out there. But with autonomous ERP, we are trying to shift this paradigm, and wanted to give you the three big things you have to keep in mind if you think about these new generations of systems. So the first one is when we talk about Copilot AI agents, also this is all the goodness you just heard about. There's all these advancements we have seen in AI. So now you have systems who can basically continuously listening and looking for signals from many data sources that's proactively triggering actions. So you don't have to be reactive. The system can help you to look at these signals, and it will replace these slow manual business processes you have in your organizations, and basically looping in humans when they are needed to help the agents to execute. So we're talking more about users becoming more like in a supervisory role than in a manual data entry role. And the second important thing to keep in mind is if you think about workflows, so it's one of the main things. You're trying to do things and they follow a certain process, a certain flow. Of course, these workflows are normally rule-based, and therefore they're very fragile, because you have to clearly define, if this happens, then do that. If this happens, then do that. If something small changes, normally the whole workflow doesn't work anymore. So now with these new concepts, we can replace them with more like dynamic workflows, because these agents also have kind of a memory, and have these reasoning capabilities, so they can kind of adapt also to new variations of this workflow. So maybe you can achieve 70% with static workflows, but now with agents, we are hoping to get maybe to 80-90% automations, because they are a little bit more flexible. And then finally, I think also super important to think about, teams will no longer have to navigate, across an ERP system. Also, in case you have seen one, of course, there's a lot of tables and entry points and menus, so it's very hard to navigate there. Since users are less doing this data entry, now we can provide them basically with kind of adaptive experiences. In the moment when an agent basically needs input to finalize a task, we can basically tailor make this UI, and you don't have to try to figure out, where do I find my demand planning, or where do I find my purchase order? So this will get prepared for you. So it's a shift, and hopefully, we can bring more and more autonomy into systems with these concepts. So now just bring it down to the one example I wanted to share. So how do we apply this basically in our portfolio? And this is just one example in supply chain, also how we infuse basically these co-pilots and agents when we talk about planning and delivering. And I think you can talk about two types of agents, I would say. There's agents who are helping you to execute operational processes. Talked about it like the procurement, as what you saw in the example, maybe like the fulfillment, and how can we basically help with agents to make them more efficient, reducing time, reducing costs, making them more reliable. And then I would say there's this other big set of opportunities for agents when we're more talking about like the planning side, the strategic processes, the simulations, the analysis, the optimizations, where also agents can improve in decision making, in the responsiveness, of course, also just the agility of the whole organization to create and react to this kind of ever-changing environments you're in. So we believe that this is really the big opportunity for AI, and it will help us to realize this vision of, for example, continuous planning. Companies sometimes are planning once a year, planning maybe once a quarter. Of course, things are changing ever faster. Now they have to maybe continuously plan, and how do we enable that across organizations? So that's also where perfectly, the work you just saw from MSR fits in there and helping us to innovate. So we have started this collaboration. I wanted to show you a little bit how this fits into a solution we are providing to our customers. So if you think about how we basically develop these planning agents, you think about planners spend majority of their time in analyzing, in reviewing, and adjusting, monitoring plans, and agents basically have the possibility here to supercharge this process and hopefully increase efficiency and also accuracy. So if you take this like in a step-by-step approach, so the first step basically is that agents offer you proactive insights when a user is analyzing a plan. We have an example here on the left. I can maybe also zoom in for a second that you can see it better. So you have your analysis. You can basically hover over this. So Copilot is like your agent who can help you all the time, and then you get the breakdown with a detailed analysis. What's going on, what are the recommendations, and what can we basically do here. So agents, can monitor this, can give a lot of insights, and then of course these alerts can be, for either differences in actuals or difference between the predictions and what you have in your warehouse, the influence of of course weather forecast or any kind of other disruptions from outside. This is a little bit this proactive listening I think I mentioned in the beginning of one of the concepts. So if you look then after insights, that's basically the first step, a very important one. But then if you go into the next step of these capabilities, we're enabling users to conduct more like an interactive analysis. So where with the help of the agents, you can kind of interact in a canvas where you can ask questions. And again, as you also saw in the demo, this natural language, you get your answers, you can do the analysis, and the UI basically adapts and showing the data. As I said, in the context, basically you have to do it. As you see an example here on the left, again, we have here this interactive canvas where you can have questions, and then you always get the UI basically based on the analysis you're trying to do here. So in this stage, of course, as outlined, where we have seen from the MSR research team, that's where we have really great impact that we can apply this industry-specific natural language understanding, to make these conversations much more optimized, in this narrow context we want to do them. And then the last one I wanted to highlight, also the third step, of course, is then driving by the agents, learning from the user's decisions. So every time a human interacts with this agent, it's also kind of a learning opportunity. So this is what I meant with static to more dynamic workflows. Also the agents kind of memorize, can understand in certain situations how to do things, and hopefully over time agents start then delivering recommendations for plan adjustments, for promotions, and basically much more reasoning over what is the intent you're having. Are you trying to increase the revenue in certain regions, and how can you do that, basically based on what you have in stock. But again, keeping the user in control, basically as a supervisor. So again, in the image you can see a little bit, this is Outlook, where agents can suggest how to adjust the plan and recommend certain actions. If you put it together, I think this is a little bit the evolution we are walking through when we think about a planner agents. So you also have to take the companies, the customers, the end users with you on this journey. It's not like that you directly start with, everything is hands-free, autonomous. You also have to gain the trust of the user. So therefore, proactive insights, and we're helping the user to understand. You also help the agent to understand what's going on. You're going to more like, proactive analysis, and at the end, if you trust the system, you can start to get more autonomy, where you either interfere in recommendations or let the system in certain, of course, guardrails do the decision themselves. As I compare a little bit with navigation systems in cars, as I know exactly when they came into the cars, but like 15 years ago, if you had a navigation system, you still saw people with a map and saying, is the system really correct? Should I go left? Or maybe I go right. The map is telling me that. But now, today, I would say nobody's doubting what the system tells you in your car. If it says left, you go left. If it says right, you go right. So you have to build this trust as well. I want to maybe make a break here if there are some questions, or if we should then jump directly into a little bit the learnings we have from a product side, or Isha, if there's anything from your side to add there.
Yeah, I don't know, Edge, should Georg just continue with his overview, and maybe we can pause at the end of his part?
Yeah.
Sure. There's one question about the whole supply chain, and is there any module or capability on the ESG initiatives that you can influence? Maybe a brief answer would. Yeah.
As ESG, or as in our terms, we have a sustainability module. So we are collecting all these scope 1, scope 2, scope 3 requirements. Also it's part of our supply chain offering. And I think it's more like becoming mandatory than an option. Also, maybe it's a little bit different by continent. As I think in Europe, of course, the legal requirements are much tighter. So I think in Europe, it's almost a must-have, and it's also a great opportunity if you really tie this together. And also, of course, a lot of opportunities for agents there. Yeah. So again, to optimize your supply chain, based, for example, on your footprints you want to have with ESG. So I think this could all be a rewards function. Yeah. But it's an important thing, and specifically in supply chain, yes, it's basically part. So I'm talking now from our solution offering for customers. It's part of our offering. Yeah.
Great. I think we can move on to the next.
Yeah. As I just wanted to, we talked about what we're trying to do. We talked about how we're trying to do it, but I guess as everybody knows, things are sometimes a little bit more challenging than it looks on PowerPoints. So I want to also share some learnings, because of course for us, and I think for everybody in industry, we are all acting in uncharted territory. So it's really like, you do something, you learn something. So therefore for us, it's super important to work with research to get, of course, the latest updates there, but also work with customers to understand, how can you apply it and how can you get their trust. So just want to highlight maybe 3 things. As you know, when we deploy these new transformative technologies, the challenge, of course, is it's a mix of behavior aspects, as how a company runs. As we talked about, users have different roles. They're not so much doing manual tasks. They're more like supervising agents. And of course, then there's a whole new technology aspect. As if you think, maybe moved from on-premise to the cloud, which was also a big shift in technologies. There were new roles, there were new capabilities, there were new ways of how you ship software. So all the things we are going through again, because now we're in an AI data first approach. So the first one I would say is really trust, as you have to earn it. It's not like that every customer says, yes, AI is great, bring it to me, I want to do it. So there's of course a lot of questions, and users need to know that they have control. So I think if users feel like control is taken away in the beginning, it's very hard to let them experiment with it. So they need to understand what these agents are doing. They have to be confident it performs well. So you have to spend a lot of time in analytics and reports to exactly give everybody a very clear page of what's going on. And specifically, if you now go into supply chain finance, also everything has to be audible, traceable. You cannot use an agent as an excuse if you are paying the wrong amount of taxes, for example, or if you use wrong products. So it's of course a function of quality of the product, which I will also discuss shortly, but also about the experience for the user. So this involves how we expose these capabilities so that they have this full visibility, as we call it, like adaptive homepage. And also we have to grant agents the right access rights, so that we can, of course, make sure in this autonomy they do the right things. But it's also about involving, ensuring that they use the capabilities in the context they should use it. So that's also, of course, helpful if you have more tailor-made models, where we have guardrails and it's clear what the outcome is. So, for example, the challenges with an open dialogue is that users, of course, sometimes lack still the expertise of crafting these precise prompts. Also prompts basically is how we basically input something into an agent via Copilot, so that we expect a certain output, but of course the prompts can influence the output. So it's also super important. And of course, if it's too vague, if it's too broad, then of course the results can sometimes be misleading or require additional clarifications. Then the second one, if you talk about reliability, which is also super important, as we must perform consistently accurate, specifically in ERP. We cannot have hallucinations. It's not like that you say, oh, this time I do my postings in finance like this, but next time I do it like that. So this is very important that this is consistent, accurate. And of course, as you maybe know, we are working with non-deterministic systems, and we have deterministic processes. So there's a lot of things we have to do there. It's a pretty complex challenge. Also, the research is also, of course, helping us, but we are trying hard to use this general purpose language models and train them in the context of industry specific nuances, in the context of a company, in certain terminologies. Also, of course, we're using these techniques like fine-tuning, RAG, to be more specific and increasing this accuracy and also being actionable. And language models, of course, they are, I would say, really excellent when it comes to unstructured data. But again, if you talk about an ERP system, it's also a lot about numbers. So it's, I think, also you mentioned at the beginning, it's a mix of GenAI, but also I call it the classical AI, how these two fields are coming together and interacting. I would say it's a bit like left brain and right brain. We also have to interact between these two sides of our brain. And then, of course, translating that to language queries into a query which we can execute in a system. also has its complexity. So we have to kind of translate this into statements we can, of course, then use against our analytical and transactional models. And lastly, of course, security. That's a top consideration for companies. As you know, it's about who has access to this data, where is this data going. Of course, there, I would say Microsoft, of course, overall, now it's not just in ERP, that's of course top priority to be compliant with all the local data laws and making sure that companies are in control of the data basically in every step of the journey. So that's a little bit again, from a product perspective. I'm sure there's also a lot of research insights we can share, but maybe take a more pause here.
Yeah, so I guess we'll share now the slides, maybe Baby new.
Yeah.
Let me say, as you share the slides, so now I think that the third part of this talk is more about the research opportunities. And next slide, Baby. I'll just say one thing about that, and you will speak about this slide. But I just want to say in general, I guess the audience here is a mix of people that are more on the applied side, on the research side. But actually, I think that one thing that I'm seeing is that the boundaries nowadays between research, between innovations and practice and deploying into things into product almost don't exist, in the sense that because it's such a fast moving space, we see a lot of innovations and a lot of research that can materialize quite early on with products. So I think it's a great opportunity for both researchers and practitioners to join forces, like we have done with Georg and other teams in Microsoft. And actually, there are fascinating research questions. Yeah, some of them won't be resolved today, but thinking concretely about autonomous ERPs and OptiGuide and such, and having like a clear vision, also leads to extremely interesting and challenging research questions. So Babin will highlight one family of such questions that are around algorithm design, and then I will speak a little bit later about other directions.
Yeah. Can you see my screen now?
Yeah.
Great, great. I was busy typing answers to the questions in the Q&A here. There are a lot of interesting questions, and I'm so busy typing the last 30 minutes, and I didn't get a chance to answer all the questions. For some of the questions, I do not know the answer. For some of the questions, it's just too long, and I'm still typing the answers.
Yeah. Maybe
so I will try to answer some of the research-oriented questions in the following 10 minutes, and then feel free to ask more questions, and I'm happy to type later on after I finish talking. And yeah, and of course, thank you for your interest on our research. So our research has many different directions. It covers end-to-end of the whole supply chain management, from the very first step where formulate a problem to the very last step of providing a solution and providing more sensitivity analysis and what-if analysis. And I will just highlight 4 major directions or major steps into this end-to-end process. The very first one is formulate. It's basically providing a natural language description of a supply chain problem or decision-making problem. And we want to formulate the problem into a ILP, which is integer linear programming or mixed integer linear programming. And in this case, the major challenges are vagueness, because when human beings are providing the description, maybe they will be too vague. They think they will have some underlying hypothesis. Oh, the language model knows my product, so they will skip some details. And how do we have the language model automatically ask questions and then formulate the problem from a natural language, a layman language, to a mathematical language? That will be the research challenge. And the second step is, after you have a mathematical formulation of the problem, there could be many different algorithms to solve the problem, because inherently those problems are NP hard. We should use some heuristics to prune the solution or to speed up. So how do we refine the algorithm, the problems, into a certain different algorithms? So that's the second step. And the third step is acceleration. So basically, given the MIL problem or MPS file, how do we do cutting plan, for instance? How do we do pre-solve? How do we do branch and bound and speed up the solver, right? So for many of the problems, small scale problems, maybe people don't care. But for a larger scale, like Microsoft scale or like a global scale, usually it will take a few hours or even days to run the solver. How can we speed up by using language model? How can we speed up by using GenAI and the traditional ML? And the last direction is very similar to the acceleration, but a different direction is approximate. For some trivial cases, we want real-time solution. For instance, Uber, you can solve optimally, but you don't have time to solve, right? Or like the Tesla self-driving, you can solve to optimal, but you have to make the decision within next 100 milliseconds. So how can we speed up, and also the approximation algorithm, how can we make the gap from the approximation algorithm and the optimal algorithm, the gap smaller? So that's the four major directions. And the next few minutes, I will talk about iClear paper, which we will publish this year, like 2 months later. It's an intern project led by me and Yishai. So it's a towards foundation model for mixed integer linear programming. So the background of the project, we want to use GenAI, but we know the GenAI performs horribly in math, right? So for instance, if 3.9 larger or 3.11 larger, even GPT can make the mistake. So how can we trust the language model to do optimization for us? It's just incredible, right? We just don't trust it. So initially we have the OptiGuide framework as introduced by Konstantina and Yishai, where we will rely on solver to solve the math problem instead of asking the language model directly. But there are still other challenges. For instance, if you have applied machine learning in mixed integer linear programming in the past, you will see it's super hard to do that. It's not like, hey, here's my image. Is the image a cat or a dog? This is a simple problem. Even human beings can, like a kid, can easily answer this problem, right? Answer the question. But for MIL problems, it's a very, very challenging and expert-driven problem. Majority of human beings cannot answer the questions. For instance, oh, here is my 2 different nodes. Which node should I branch in the next step? Even human beings cannot answer the question correctly, right? And also, in terms of the scale of those problems, it's super hard. For a regular image, maybe using iPhone, right? You can get 3,000 by 3,000 pixels. So what? But for mixed integer linear programming, it's easily exceeding millions of variables and constraints, and easily exceed billions in a global scale. So the scale of the problem, the diversity of the problem, makes application of machine learning to MIL very, very hard. And usually, traditionally, people use ad hoc solutions. Basically, for each problem, they will build a separate machine learning model or graph neural network for their problem. But we don't want to do that. We want to build a world model where we have one graph neural network or one deep learning model, which can help all the mixed integer linear programmers. And for here, we leverage the language model. So we test our framework in 4 different tasks. One is for the linear programming approximation, estimating the gap. The second one is interacting with human beings. Given a super large scale of a problem, how do we interpret the problem? How do we communicate with human beings? The third one is learning to branch and cut to speed up the solution by using the deep learning model. So, and also we want to test our model in unseen problems. So the scale of our experiments is 1,000x compared to the previous studies, because of the language model. So how do we even get the language model here? Because I just described so many machine learning stuff. So we use the concept of evolution algorithm, and the evolution algorithm will take the seed problems of to the language model, and then it will do the evolution, which means through adding more constraints, mutate the existing constraints or variables, cross over several different optimization problems, create new problems, and delete some redundant constraints or variables. By using those types of LLM evolution techniques, we generated a couple thousands different distinguished supply chain problems and optimization problems. And then from those problems, we generate the code. We generate random data. So those data will be fed into the graph neural network to learn, for instance, the language, to learn the gap, to learn through the reinforcement learning how to branch and how to cut. So one more sentence about graph neural network. Why we design graph neural network is because it's much faster than transformers and a language model. You might know, right, the Gemini GPT, they can have 1 million tokens for today, but still in the scale of optimization, 1 million tokens is not enough. Sometimes there are billions of tokens, and it's not scalable to using GPUs to train a language model with billions of tokens. And moreover, even if it is scalable, at the inference time, when we want to use the model, we usually are limited by the IoT device, by the iPhone, by the Tesla GPU, right? So we want to make the model smaller, but it can still handle a large set of variables. That's why we aim to use the GNN here. And here is our result. On the left-hand side, we compare the state-of-the-art performance previous graph neural networks in orange, and the blue are the graph neural networks we trained, right? And you can see our performance is significantly better than the state-of-the-art. Wow, even though it's still not like more than 90% or 95% accurate, but it's already a big jump from the state-of-the-art, which is 2 years ago or 3 years ago, before the language model and the GenAI area. And the right-hand side is just an ablation study. We want to study how important is the diversity of the data. So on the x-axis for each of the diagram on the right-hand side is the number of instances of or the number of classes. And the y-axis is basically the error rate, which we call deviation, or the accuracy. And you can see as the diversity goes up, the performance also goes up. But of course, there is a diminishing of revenue here, as you can see, but it's very common. I think we can just vaguely call this diagram the scaling of graph neural network for mixed integer linear programming. So we basically find a scaling law here, how to improve in the future. And we also have some other future directions. As we've already mentioned, we want to do reliable algorithm design to speed up the combinatorial optimization. We also include optimization and reasoning in language models. How do we reason about the decision made by the solver, the decision made by the language model? And we also want to integrate in different supply chain processes with the GenAI, including the ERP, sensitivity analysis, and other analysis. And that's all from my side. Thank you so much. So now I will just stop sharing and I will let other people speak. And
go back, Babin, go back to typing now. I think you need an agent that will help you.
Yeah. Yes, for sure, for sure.
Okay.
So I need an agent to represent myself to
exactly
to reply all the questions.
Yes,
I was trying to answer a couple of questions too, but I hope they were directed to me. Yeah, so I can not sure.
Thank you.
Georg, Ece, can I add a couple of things to Babin's? Babin, maybe you can put the last slide as on the background, and then we'll.
Konstantina, can you help me do that because I'm typing? Yeah.
Yeah.
Yeah. Let me.
So just the last. So I think just a little bit providing more context about the research. I would say that one thing that we see kind of common theme, as I mentioned, is that LLMs don't do everything, and we use them, in a clever way, and many times it's an hybrid ML solution. So in the algorithm, in that paper, in that Eichler paper, what was nice just to highlight that we used we know that LLMs are good in generating code. So what we did is actually we generated thousands of different mixed integer linear program classes, right? Classes which are like templates. So LLMs help with the perturbation and creating these classes, which is kind of hard to do manually or by humans, creating all sorts of different diversity of classes. And then each class on its own, based on each class on its own, we can create an unlimited number of instances. So we take all this kind of GenAI part, generate unprecedented number of integer linear programs, something that is we want to kind of highlight, and as a preview, as kind of promoting this article, is that we are actually going to release this data I believe, the largest amount of integer programming instances. We're gonna make them public, and that's facilitated by LLMs. But again, to do the actual task of predicting the integer programming value or helping with branching techniques, we still resort to traditional machine learning like GNNs. So that's one important aspect, and you saw it also in the what ifs in our implementation. That just to emphasize, and it was a question that I answered in the Q&A, that the actual combinatorial solver is still doing its work, because the what ifs, we use LLMs to translate into code, and but the code itself is a perturbation to an integer program that we run under the hood. The user doesn't see that, and we give them back the answer. So that's one thing. One last thing that it's the last bullet, but I want to sort of double click on that, integrate different supply chain process. So I think, and maybe Georg can say a few words, he definitely has a lot of experience in this area. Some of the kind of main processes, such as, forecasting and trade, are done separately today. And with GenAI, you can kind of tie together different processes. And us as optimization expert, of course, if you look at like end-to-end and tie together different processes, you can also obtain lower costs, higher value, and all that. So this integration, things that seemed impossible in the past, are now seem more realistic with the help of GenAI. So I'll pause here. Georg, I don't know how many questions you have there, and comments you want to add to that.
Maybe I can add to your last point. I think there's two aspects. The lines between applications getting more and more blurry, as you know, the CRM processes, the supply chain processes. Also, if you think about industries like retail, you have the person in the store who wants maybe something which can, of course, trigger a product delivery, a product order. Also, all these kind of things which goes from a sales process more into delivery, fulfillment process. I think these end-to-end processes will get easier, but I think also maybe faster. So specifically also in planning, planning cycles have changed, but you also have to then be able to do planning. Because if your planning process takes 2 weeks, you cannot do it every week. Yeah? So how can you basically reduce all these manual interactions, which normally take most time, and that's basically hopefully a step into the direction of continuous planning. So if everything is automated, if agents can do everything in the background, you basically can continuously trigger your planning process and basically do it based on capacity. So I think there's a lot of changes coming where we can really optimize processes and increase productivity and output.
Yeah, Ece, maybe
Great.
you have a few things to say.
Yeah, absolutely. Well, thank you so much for the insightful talk. Actually, the questions clustered around like algorithm design, OR algorithm design, model design, and then the types of use cases, and then especially the reliability aspect in the application when it comes to applying those at scale, right, at the enterprise level through ERPs or otherwise. And when it comes to autonomy, there are so many moving parts integrating the LLMs, the agentic systems with OR capabilities. So it's incredible work. Thank you so much, team, and we'll definitely asking for more in the next few months from you, and we'll be following your work closely. What I will do is we are recording this, so I will distribute this recording to the audience, and then if you have additional things to share, I know Bibin has shared the research papers that are associated with this work, and we will also distribute that as well. Thank you so much. Great talk, and hopefully we will keep you posted, everyone.
Thank you.
Thank you very much. It was great being here.